I think not all come to the class, right? Only 15. What happened to the others? 10 didn't come. If you know someone in this lab, can you call them for them to come to the class? Okay. Okay, now we'll move to experiment 7. Okay, experiment 7 is not only part B, you need to do part A and part B, and the rest already done. Okay, now let's recall. What is BJT? So I need your help. Go to the chat box. Can you write any keywords that you can understand from the word
2 PN
BJT?
junction diode.
PN junction diode. Okay. Correct, Prabal. Okay. How about the rest? For those who don't want to turn on the microphone, I give you 30 seconds to write any keywords that you understand about BJT. So I'll wait about 30 seconds. Prabal, you ask something? I want to ask about last week experiment. Is it about diode, Prabal? Peak to peak 9 volts. So for
Yeah.
today, we should use what do you mean? Can you explain? You said
For the theoretical calculation,
okay.
we output. We set we input peak. We input peak value, right?
Yes.
Peak value.
Okay.
So we will divide 9 by 2.
Yes, but the
Then we
output.
will calculate.
Mm.
Then we calculate the output, right?
Yes, correct.
Okay.
Yes, correct. If we output, your peak to peak still the same because at the negatives part you don't have any output, right? So only input you need to divide by 2, but the output, the peak to peak will remain the same. Okay, Pravin? Is it clear? Okay.
Yes.
Okay, so how about the rest? Can you answer inside the chat box? Fadila, Aziati, Firdaus, Farzana. So we have 3 terminals, collector, base, and emitter. Shazwan, what is BJT, Shazwan? Shazwan, are you there? Okay, I just want to share with you. It's about this online class, right? So when we are in the online class, is a challenge for you, the students, yes, and also challenge for us as a lecturer. Why? Because in the face-to-face class, we can directly see your face and get your response directly. But in the online class, on top of you didn't turn on your camera, I don't know whether you are there or not. I know you have a lot of workload, but it's actually the manners when we are getting the knowledge. So when you come to the class, if you are not ready, this class is optional. If you are not ready to come to the class, you mean you have option not to come. But once you decide to come to the class, we as a lecturer hope that you are ready to be there and to get the knowledge. And this is also a manners when we call upon your name and you keep quiet is quite frustrating for us as a lecturer. In the department meeting last department meeting, one lecturer also give the same frustration actually because we have been in the online class since how long you have been in online class? I think 1 year and one since last year, right? Since last year, right?
Yes, very nice.
Yes, since last year. Right. So the motivation become days and days become decreasing. So we don't know this when this pandemic will be end. So it become very we are now in a bad condition now. Become 6,000 case, right? So this online will prolong. We don't know until when. Is it until your final year? We hope not. We hope we will pray that because online class is it's not the best way to teach actually, but we don't have any option. So as a we hope that it's okay if you don't turn on your camera, but when we call your name, it's also uh, we hope that you answer, okay? Because this is a two-way communication. Remember the first class I say, when you learn is not when you call someone, it's not you just send. You even you learn about op-amp, there is some feedback, right? With that feedback, you can amplify. If you make that analogy, when you learn about the knowledge, if there is only one way communication without feedback, we don't know whether you understand or not. If you try to ask in class, you can just put in the chat room. So your feedback will motivate us as a lecturer. It just come from my heart because day by day the class seems very quiet. When I call, nobody responds. So I don't know whether you are there or not, whether you understand. There is no feedback in the loop. So for us, this is our responsibility to make sure that you understand. So I hope you can respond not only on this class, but also on other class. Okay? Okay, now let's go back to this NPN and P type. Hanim, what is the difference between NPN and PNP? Hanim?
Yes, madam.
What is the difference between NPN and PNP? What do you think?
Is the difference is sorry to explain.
Arrow.
I type it, madam. I'm not good explaining.
Arrow. Can you remember the arrow? NPN. The arrow is pointing out or pointing in. Can you see my handwriting here?
Yes, madam.
Okay.
NPN is pointing out.
Okay, correct. Okay. Okay, one more thing. When you respond, it's okay for you to make wrong answer. If you don't know, you just say you don't know. We not really want to expect you to answer correctly. Just to hear your voice also is like you give appreciation. You give heart to this class. Okay, so it's okay if you say you don't know. I'm okay. Okay, so how about PNP, Hanim? The arrow is pointing in or pointing out?
Inside.
Inside.
Pointing
Okay,
in.
pointing in. Okay, so there's a difference. Okay, for your information, electronic and this lab, we only cover on NPN. PNP is not covered inside the syllabus. Okay, Shanas, you say about 3 operating regions. So what are the operating regions, Shanas?
Activation,
Active.
saturation, cut off.
Yes, active, saturation, and cut off. For you to make as an amplifier, you are going to make it in active, saturation, or cut off.
Cut off.
Cut off. Amplifier. If I want to make it as an amplifier, if cut off, what does it mean by cut off, Shanas? Cut off means the transistor is on ke off?
Off.
Off kan? Kalau off, dia tak it can't amplify. So, cut off is not the answer. How about active? What happened during active, Shanas?
Active amplifier turn on.
Yes, so active means the transistor turn on, right? And then it can amplify. Okay, thank you, Shanas and Hanim. Okay, Alisa Izati, 3 separately doped region. So what is the 3 separately? What do you mean by 3 separately, Alisa? Alisa?
Yes, madam.
Okay, 3 separately means here is
Um,
what is the 3 region name? N
NPN.
NPN, right? Okay, so here is emitter, base, or collector?
Emitter.
Emitter. The middle one is
Base.
base, and the third one is collector, right? Collector. Okay, so and the rest also. Okay, thank you for Anis, Fadilah, and Akil. So I believe by now you already clear what is BJT because you have learned this inside the class. Okay, so now this is the one that you are going to do the experiment. So this is how BJT looks like. In your class, you only see this one, right? But inside the lab, you can see the real BJT. So if you see BJT, there is a polarity. So this is the flat surface. If you have chance later to come to the lab, so you can see this is the flat surface. The first pin here is collector, second is base, the third one is emitter. You cannot interchange it because between C to B, you have a diode, between B to E, you have another diode. Okay, now part A, where you're going to do the experiment, the simulation. So we have the IV characteristics. So what is IV characteristics? Anybody can remember?
Current voltage characteristics.
Okay, current voltage characteristics. So this is I, this is V. What is the What is the I here? Sekejap lagi. What is the I here? IC, IB or IE?
I see.
IC. What is the V here? VCE or VBE?
VCE.
VCE. Okay. So how is the shape of the graph? Shape. Straight line?
No.
Is it like this?
Yes.
Yes. And what is the point here? Voltage or current? What differentiate between these three lines? Line 1, line 2, and line 3.
VBE 1, VBE 2.
VBE 1. Not that one. This is a BJT is a current control device. We call BJT is a current control. Current control the amplification. So this line need to be current. So what current is that? This is already IC. So what do you think the current will be here?
IB.
IB. Okay. For V, you can see on the MOSFET later, the next chapter in the class. So you can see the same graph. This is for MOSFET. The other transistor, this is a V. So this is what we call voltage control device. But for BJT, we call this one current control because this IB will control the IC. How IB can control the IC? What is the formula between IB and IC? What is the formula between IC and IB?
IC is equal to beta IB.
Yes, beta, right? Beta. Beta must be more than 1 or less than 1?
More than 1.
More than 1. That's why it amplify, right? And amplify the current. Okay. Okay, this is the graph. You are going to plot this graph. You're going to have the circuits and then you're going to have each point to plot this IV characteristic. Okay, at this IV characteristic, just now, I think Shana said about 3 regions. So which one is cut off? Which area is cut off? Which area is saturation? Which area is active? If I say this region, this is cut off or active or saturation?
Saturation.
Yes, saturation. Okay, where is cut off? This is cut off or active? This region B. Cut off. It is off, right? When it is off, there is no current. When this is off, there is no current. Okay, where is the active? Active as in the middle. This is what we call active region. So for you to amplify, you need to make sure your Q point means your IC and VCE need to be in this region, active region. So this process what we call biasing, the one that you learn inside the class. Okay. Okay, now how you can get this graph? You need to have this circuit inside the Tinkercad. So if you see here, there are three pins here, A, B, and C. And here also we have A, B, and C. So what does that mean? This is a potentiometer. So what is potentiometer? Najmi?
Variable resistor.
Okay, variable resistor. Means you can vary your resistor. How you vary your resistor? So this is what you are going to see inside the Tinkercad. So you have 3 pins, same as the circuit. So one is VCC. So point A here, you connect to VCC. Point B here, you connect to collector for 10K, 1 mega ohm to the base. So you have potentiometer 1, potentiometer 2. And the third one, you don't need to connect. Or if you want to connect, you can directly make it to ground. So because the other section already submit, they connect it to the ground, you still can get the same result. Okay. And how you're going to make sure this is 10K and 1 mega ohm? So when you open your Tinkercad, you double click at here and then we display how many ohm here. So you need to select here for potentiometer to 10K, potentiometer 1. What does mean by 10K here? Professor said just now variable resistor. So 10K means what? If you vary this variable, what is the maximum value here?
10K.
10K, right? So it can be from 0, 1, 2, 3, 4, 5, 6, 7, or 8 or 9. So this is the maximum is 1 mega ohm. You are going to set the maximum. Okay. So in the experiment, what you need to do is you need to vary this 1 mega here. 1 mega here is for you to get two different IB. So IB1 is one value, IB2 is another value. So the base current need to be in micro or in milli. What do you think?
Micro.
Micro. Okay, it must be micro. So you can set let me 20 and 40. So first you set 20. How you can get this 20? If you see these words here, vary the 1 mega ohm. So you need to vary this one. How you're going to vary? You just change the knob here until you are going to have this one. You're going to have multimeter current to measure the current. There is IB. Okay. And then once you got, let's say you got 20 microampere. Next, you need to vary the other one to get what? To get this VRC. And sorry, potentiometer 10 kilo ohm here. We're varying 10K. Set the VCE. So means at this, where is the VCE? The output, right? This one, VCE. So next, you need to vary this 10K to vary this VCE. Just now, you are going to vary this 1 mega ohm to get the IB, but you're going to vary this 10K to get the VCE. So I will show you the table first. Okay, this is table that you're going to need to fill. First, how you're going to get 20 microampere, you need to vary which potentiometer? 1 mega ohm. 1 mega ohm until you get 20. So once you get 20, you stop varies the potentiometer. Next, you need to vary the potentiometer at your VCE, the 10K. And then you start to vary until you get the VCE 0.1. And then you write the value. Okay. And then you have another multimeter at the VRC. So where is the VRC? Where is the VRC? VRC is here.
1 kilo ohm.
Yes, 1 kilo ohm. Why you need to have this VRC? Because you're not going to put directly the measurement of current here. So you're going to get your IC from VRC. So how you can get your IC from VRC? What is the formula? Ohm's law. You get your VRC, you know your RC. How you can get your IC? Collector current.
VRC or RC?
Yes, VRC over RC. So what does that mean? VRC is you're going to measure. IC, you're going to calculate. IC equal VRC over RC. So means how many multimeter that you need to put? One is for IB. Another one is, yes, Pravin?
3 multimeter.
3, correct. One IB, another one is VCE, another one is VRC. 2 voltmeter, 1 ammeter. Okay. Next, you are going to calculate. Remember this calculate. This is not you measure, you calculate. How you can calculate your IE? You already know your IC, you already know your IB. What is the formula? IE equal to?
I is equal to IB plus IC.
IB plus IC. Okay. So this both you calculate. The one that you only measure 1, 2, and 3. 1, 2, and 3. So once you are done with the 20 microampere, means for this part, you will have one graph. This is for IB equal 20 micro. So you have many plot here. And then once this graph done, change to 40, you are going to get another graph. Okay. So means as the base current increase, the IC current will also increase. So if you see this graph, plot this inside the Excel. So you're going to get this data. Where can you get this data? From this simulation here. So this is the circuit looks like. Where is the potentiometer? One is 1 mega ohm to control what? To control the base current. Okay, remember how you measure the base current? How you measure the base current? Break the circuit, series or parallel?
Series.
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 You need to break the circuit, remember? Okay, so please take note, the circuit here will be a bit complicated, a lot of wires. So if you see here, between I to B is already break the circuit, and then you connect with the resistor. This is RB and this is RC. Okay, and then this also you measure the VCE. How you can control this VCE? By changing the knob at this 10K. And the last one, you are going to have another multimeter at the RC. Why you need this RC? Because you're going to have the current of the collector. So don't measure the current directly by ammeter. You can get the current of IC by having this VRC. So you can try first. So at this experiment simulation, it make the third one no connection. But in the other section, they already submit, they also make it ground, so they still can get the result. So you try to make it no connection first. If you can still get it, you can make it ground. Okay. So is it any question? Do you clear what you need to do for part A?
Yes.
Yes. Okay. So this is about part A. So once you are done with part A, make sure you discuss your observation, why you get the result like that, and then prepare the lab report. Okay, so this is all about part A. Okay, for part B, you are going to do circuit simulation for voltage divider. So why you need biasing? What is the purpose of biasing? Why you need to learn biasing in the class? Najmi?
Get active region.
To get active region. Why you need to have active region?
To amplify the signal.
Yes, to amplify the signal. Okay. The one that you are doing biasing, this one is a DC analysis or AC analysis?
DC.
This analysis.
DC analysis. So you are going to find Q point. What is the value of this Q point? I what, V what? IC, IB or IE?
I
IC. And another thing that you need to find is VCE ke VBE? VCE. This is related to the graph just now. Graph just now is IC and VCE, right? So when you have this graph, when you have a load line, if you learn in the class, you have a load line, right? So you have this line, and this is your Q point. Why you need this Q point? Because you need to make sure it is in the active region in order for it to amplify. Okay. So there are three types of biasing. The first one is collector to base, and another one you learn in class. So we go to the third one, that is voltage divider biasing. Okay, so can you remember this graph? What we call this graph? If you can recall in the class, is it IV or VTC? VV now. What we call this graph?
VTC.
VTC. What is VTC?
Voltage transfer characteristic.
Yes, voltage transfer characteristic. Okay. So which one is active region? 1, 2, or 3?
2.
2, right? So you need to make sure. Now you learn about biasing. Biasing. Why you make your life complicated to learn this one? Because you need to have proper biasing. Proper biasing means you need to make sure it is in active region. When you amplify, when you extrapolate the line, you can see the proper amplification happen here. Okay. But what happen when you have a half Q point is here, this part is active, but the other part here is number 3 is saturation or cut off.
Saturation.
Saturation. Okay, so half active, half saturation. So when you amplify, so this is not a correct amplification. So only half got amplified, another gone, right? So this is improper biasing. So that's why you need to learn by biasing. Okay, so the most common biasing inside your electronic, this is a question that must be asked inside your final exam. Okay, so this is the original circuit. What we call this biasing is called voltage divider. So in this lab, you are going to derive, sorry, not derive, you're going to calculate what is the IC and VCE, the Q point for these circuits. Okay, so what is the first step? You have R1 and R2, right? So you have
Turn off.
RTH. Yeah, you need to change this one to DC analysis or AC analysis.
DC.
DC. What happened to the capacitor during DC analysis?
It acts as a short circuit. Sorry.
Short or open? DC analysis, capacitor short or open?
Open.
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 Okay, open. So open means your circuit only remain the middle one. From this middle one, what happened to the VCC? Remain or shorted?
Remain.
Remain, okay, because you need supply to do biasing. And then you have R1 and R2 change to RTH and VTH. So I will not repeat this one. I think you already learned this inside the class, but you need to apply this one inside the lab. So you need to do BE loop and CE loop. Okay, so this is the steps. So the circuit that you're going to simulate inside the lab is this one. This is what we call voltage divider biasing. You already remove the capacitor and the input and output. It remain only DC supply and 4 resistor. So you need to connect like this, okay, with this 4 resistor, okay. What you need to measure is the R1, R2, RC, and RE. Okay, now look at I1 and I2. So where is I1? Between R1. Where is I2? Is between R2. So you need to put your multimeter here and your multimeter here. So from I1 and I2, how you relate this with IB? This is I1, this is I2, and this is IB. How can you get your IB? How can you get your IB
IB
from
plus I2. I1 is equal to IB plus I2.
I1 is equal to IB plus I2. KCL, right? Current entering equal current leaving. So then from I1 and I2, you can get your IB. Okay, so this is the equation. Okay, now another table that you need to fill is the whole here. Okay, for this IE and IC, how can you measure IE? You just put your ammeter here. IC also, you can just put your ammeter somewhere here. But for VBE and VE, so what does that mean by VBE and VE? Okay, now, if I want to measure VCE, where should my multimeter probe goes? So the positive will go to where? I want to measure VCE. Positive will go to which pin? I want to measure VCE. Positive will go to which pin?
C.
C, right? C. But how about negative?
E.
E. Okay. But if I want to measure VC, now you are in VC.
IC and RC.
Why I can change the color? So VC. So where I should make VC?
Plus RC.
Plus should be goes to here. But negative? Is it go to E or goes to ground? Where should the negative pin goes? This one is VCE. This one is VC. What do you think? Is it the same point?
Connect with parallel to RC.
Parallel to RC. You mean negative goes to this?
No,
That one
positive.
is VRC, not VC. The one that we measured just now, this one, right? This is VRC. But now I want to measure VC only. The negative means the negative needs to goes to ground. What does that mean by VC? Means VC with respect to ground. VC with respect to ground. So let's see another 1 minute. Wait, let me share my screen. Can you see my screen?
Yes.
Yes. Okay. Okay. Now it's not. I put wrong notice. Can you see my screen?
Yes.
Okay. So okay. Now change to why I can't clear. I cannot. Wait, I cannot use the pen. Okay, never mind. I use this pen. Okay, if I want to measure VBE, this one is direct, right? This plus connect to base. Where is E goes? E to ground. Sorry,
Ground.
the ground or to this emitter?
Ground.
Ground. Okay, purpose say ground. How about Iman? Iman. How about the rest? Farzana? Purpose says ground. E to ground or to E? The negative here is to ground or to the emitter?
Emitter.
Emitter. Now you change your answer.
Emitter.
Emitter. How about the rest? Which one? Emitter or to ground?
Emitter.
Emitter. Okay. Because you have RE here. You have RE. It matters. Either it is to ground or to emitter. So this one should be to emitter. But if I want to measure VE, what does mean by VE? Positive to emitter, correct? Negative to where?
Ground.
Negative to ground. So I hope by now you get the concept. VE means to ground. VC means C to ground. VB means B to ground. So because you need to measure here. VB, so it matters where you put the probe, especially at the negative terminal. So this one with respect to ground, this one with respect to ground, this one with respect to ground. But what is the relation between this VB and VCE? VCE is equal VC with respect to ground minus VE with respect to ground. What will happen to the VBE?
You cannot see your cursor, madam.
Oh, see what happened today. Wait. Just now you can see. Suddenly, can you see it now?
Yes.
Okay. So now VCE, what does it mean by VCE? VC with respect to ground minus VE with respect to ground. How about VBE? Also the same. VB with respect to ground minus VE with respect to ground. So that's how you can get your VCE. So VB means B to ground. VCE means VC to the terminal E. So it matters when you put the probe inside your Tinkercad. Okay, is it clear? Can you get the point? Any question? Farzana? Fadilah? Any question? No. Okay. Okay. So that's all for the part B. Now and next you need to discuss as usual inside your discussion. Okay. Okay. Please take note. For your theory, so you need to change this to the theory calculation where you have VTH and RTH. Okay. Okay. Beta is not given inside part B. Now, how can you get the beta? from here, you are going to get IB, right? So let's say your IB from I1 and I2, you got 20. I just give a random number here. And then you measure your IE, you measure your IC. So let's say your IC here is 5 milliampere. So from this simulation, you can calculate your beta. So you got your beta from IC over IB means IC measured and IB measured. Let's say your beta here is 85. So use this beta for your theory calculation. So means hold your beta to become 85 and then you can proceed on the theory because the beta is not given for the theory. So use your measured beta and then put it inside the theory analysis. Okay? Because in another section, a lot of people ask about this. So I just give you update information. So use your beta from your simulation. Okay. And then include all this inside your discussion. So it means you have two part of discussion. One is part A, another one is part B. And as usual, you calculate the error. No need to have all error, only one for each. And then you can prepare your lab report. This will be the last lab report for this semester. Okay, software to use, only Tinkercad. When you need to submit is 3rd June 2021. So 2 weeks from now. So you have 2 weeks for part A and part B. So if you have any question, you can let me know earlier. Okay, any question regarding the lab? Is it clear?
Yes.
Okay, so I will let to announce. Okay, since this is last lab for this semester. So on 3rd June, you're going to submit your lab report, right? On the same day, you're going to have your quiz and final lab test for electronic part only. So means here only 3 experiment, diode, BJT, and another one is op-amp. So you only diode, BJT, op-amp. Yeah. So you need to have 3. You need to revise these 3 experiment, and then prepare for your quiz and final lab test. So how is this quiz and lab test works? Same like before, only in Google, not Google Classroom, Google Form. I will upload inside the Google Classroom. Okay. So you have theory, some calculation, and some simulation, either PSpice or Tinkercad. So it can be, for the simulation, it can be from these 3, either diode, BJT, or op-amp, these 3 experiment. So time given is 1.5 hours like usual, and all it will be inside the Google form. So this exam is open book. You can just refer to your book and then just try to answer it. So 1.5. When is the lab test? This will be our last class, 3rd June. So on 3rd June we don't have any Zoom. Today's class is the last Zoom class. So 3rd June you just submit your lab report and then ready for your quiz and final lab test. And I will release the marks except the lab test before on week 14 inshallah. Okay. So with that, do you have any question regarding experiment 6 or 7? Any question? Yes, no?
No, madam.
No, madam.
Okay, so
No,
with that,
madam.
we can end our session. Okay, since this will be our last Zoom class, so I would like to apologize for any shortcomings. So I hope you, in any throughout your journey at IUM, all your effort will be blessed, inshallah. And do pray for all of us, especially for our brothers staying in Palestine and for us, so the Allah will take COVID away, so we can go back to IUM to have a normal life in IUM, inshallah. Okay. So with that, can I have one brother to recite doa for our last class? Any volunteers? Firdaus, can you recite doa?
Yeah, sure.
Okay, thank you.
Bismillahirrahmanirrahim. Alhamdulillah Rabbil Alamin. Hamdan wafi nam'u kafi mazidah. Ya Rabbana lakal hamdu kama yanbaghi lijalali wajhi sultanik. O Allah, make useful for me what you have taught me and teach me knowledge that will be useful to me. O Allah, I ask you for the understanding of the prophets and the memory of the messengers and those nearest to you. O Allah, nothing is easy except what you have made easy. If you wish, you can make difficulty easy. ربنا لا تزغ قلوبنا بعد إذ هديتنا وهب لنا من لدنك رحمة إنك أنت الوهاب ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار صلى الله على سيدنا محمد وعلى آله وصحبه وبارك وسلم والحمد لله رب العالمين.
Amin. Ya Rabbal Alamin. Thank you so much Firdaus for beautiful dua. So we'll end our class with Tasbih Kifara and Surah Al-As.